Hello everyone, welcome to the channel. In this video, we will see a problem on impulse and momentum. The problem states that two smooth spheres 1 and 2 having a mass of 2 kg and 4 kg respectively collide with initial velocities as shown in the figure. If the coefficient of restitution for the spheres is E equal to 0.8, determine the velocities of each sphere after collision. This problem is similar to the previous problem, but here the velocities, that the initial velocities, are having some inclination with the line of impact. Okay, if you see here we have a center line, so this is nothing but the line of impact. And when the bodies are colliding, so this line is called as a common tangent. This line is called as a common tangent, that is a vertical one. The collision is happening in the horizontal line, so this line is called as a line of impact. Okay, the vertical line is called as a common tangent. Okay, now we have two bodies or is two spheres. The velocities are inclined, that means we have to resolve the velocities. So this will be like this. So here 2 sine 30, this will be 2 cos 30. So cos 30 are nothing but u1x, because x component, and sine component nothing but u1y. And similarly here also we have two things. We have to resolve these two velocities. This is u2y, since it is a vertical one, so 4 sine 60, and this is u2x horizontal component 4 cos 60. Okay, so we have resolved the initial velocities. Now what will be the final velocities? We have to determine what will be the final velocities. So just imagine, so when we have your initial velocity in this direction, the final velocity will be in this direction. The final velocity will be like this. So here we'll have a theta 1, because we don't know in which angle this velocity is 1 will have. So this is v1, and similarly here we'll have the velocity 2. This is theta 2. This will be v2. Again this v1 and v2 are inclined, so here again you will have a resolution as well. This will be vertical one, so v1y. This is horizontal one, so v1x. And here also we have two components, v2x horizontal component, v1y vertical component. I hope you understood this FBD. This problem is called as a oblique impact, because here the velocities are inclined. Okay, now first of all we'll start solving the problem by given data. So given data, we have two spheres, one is 2 kg and 4 kg. So I'll write mass 1 equal to 2 kg, m2 equal to 4 kg. Okay, so velocities, initial velocities, we have u1 equal to 2 meter per second and u2 equal to 4 meter per second, and they have given the coefficient of restitution e equal to 0.8. So you have to find v1 and v2 for the oblique impact. Okay, so we know that by law of conservation of momentum along the line of impact, why I'm using along the line of impact? Because here we have two velocities. We have component velocities of initial velocity, right? So here we have a x component and also we have a y component. We'll be taking only those component velocities which are having in the same as line of impact. Here the line of impact is having horizontal direction, so we'll be taking only the horizontal velocities. So the formula will be now m1 u1x plus m2 u2x. This will be equal to m1 v1x plus m2 v2x. Okay, so here it is not nothing, just a m1 u1, it is the component of those velocities. Okay, so you have to make sure that we are using the components because it is an oblique impact, will have a inclination. So m1 is 2 kg into what is the u1x. So here the component of u1x is 2 cos 30, 2 cos 30 plus m2 is 4 kg into u2x is 4 cos of 60. u2x is 4 cos of 60. Now you have to check the direction as well. The u1x is moving from left to right, so it is positive. u2x is moving from right to left, so it will be negative. So here it is minus 4 cos 60. So this will be equal to m1 is again 2 v1x plus m2 is 4 v2x. We can put it in the calculator. Okay, so again you have to check the v1x also. So v1x is away moving from left to right. Okay, sorry, right to left. Again this will be minus. Again v2x is moving from right to left. So left to right it is positive. So v1x will become minus. Okay, so you put in the calculator. So 2 into 2 cos 30 plus 4 into minus 4 cos 60. So this is equal to minus 4.5358 equal to minus 2 v1x plus 4 v2x. So further we can simplify it. So we'll have minus v1x plus 2 v2x. We can divide this by 2. It is minus 2.2679. This is our first equation. Now by coefficient of restitution, because they have given coefficient of restitution, E equal to 0.8. Now we know the formula for E. E equal to velocity of separation divided by velocity of approaches. Now according to this, what are the velocity separation? Again it is a horizontal direction. So here the velocity of separation is nothing but v1x and v2x. These are the separation. So we know v2x minus v1x. Why minus of minus? Because v1x, the direction of v1x from right to left. That is the reason we are taking minus. So divide by velocity approach. Approach is nothing but u1. So u1x minus of u2x. Okay. u1x minus of u2x. So E is 0.8. So v2x plus v1x divided by u1x is 2 cos 30. It's moving from left to right, so positive 2 cos 30 minus of u2x. So u2x is moving right to left, so negative 4 cos 60. Negative 4 cos 60. So we'll have v1x plus v2x equal to, so 2 cos 30 minus, so ultimately it will become plus 4 cos 60. So into 0.8. It is 2.9856. This is our second equation. Now again we have the term in terms of v1x, v2x equal to some constant. Again we can put it in the equation. Here we have two unknown equal to constant. So first equation, the coefficient of v1x is -1 and 2 equal to minus of 2.2679. The second equation, the coefficient of v1x is 1, v2x is 1 and the constant is 2.9856. If we solve, v1x equal to 2.7463 and v2x 0.2392 meter per second. So we found out one component of the collision velocity, after collision velocity, that is v1x and v2x. Now we have to find v2y and v1y and v2y. So how are you going to find out? Because here the impact is happening in the horizontal direction, not happening in the vertical direction. So what happens is that whenever we have an impact in the horizontal direction, the vertical component of the velocities of initial velocities will be equal to the vertical component of the final velocities. That means the velocities are conserved in the vertical direction, or else the velocities are conserved in the common tangent direction. So we can write this statement as component of velocity before and after impact are conserved after impact along common tangent is conserved. That means it will remain constant, is conserved. So we can say that u1y is equal to v1y and u2y is equal to v2y. So now what is v1y? It is u1y. u1y is nothing but it is 2 sine 30 is going upward, so positive. 2 sine 30 and here v2y is equal to u2y. So u2y is 4 sine 60. Again it is going upward, so positive. So 4 sine 60. So v1y will be equal to 2 into sine 30. It is 1. That is v1y is 1 meter per second and v2y equal to 4 sine of 60. It is 3.4641 meter per second. Okay, so now we found out the components of the velocities. We have found out the components of velocities, that is v1x, v2x, v1y, v2y. So we know that to find the velocity, that is v1, this will be equal to root of v1x square plus v2x square. And to find out the velocity of v2, this will be equal to root of v2x square plus v2y square. So here it will be y. So v1 will be equal to root of v1x square. v1 is 2.7463 the whole square plus again v1y. Okay, so v1y is 1 meter per second and v2 equal to v2x square. v2 is 0.2392 the whole square plus v2y is 3.4641 the whole square. So root of 2.7463 the whole square plus 1 the whole square we'll get V1 equal to 2.9226 meter per second, and V2 equal to root of 0.2392 the whole square plus 3.4641 the whole square. This is V2 equal to 3.4723 meter per seconds. We found out the velocities V1, V2, but again we don't know the angle of the velocities, right? Because here we have to find theta 1, theta 2. So again we can use the formula called tan theta inverse, that is theta 1 will be equal to tan inverse of v1y divided by v1x. Here theta 2 will be equal to tan inverse of v2y divided by v2x. So tan inverse of v1y is 1, sorry, v1y is 1, v1x is 2.7463. This will be equal to tan inverse of v2y is 3.4641 divided by v2x is 0.2392. So theta 1 will be equal to tan inverse of 1 divided by 2.7463. This gives me angle of 20 degree. So theta 1 is 20 degree. Theta 2 equal to 3.4641 divided by 0.2392. So this gives 86.049 degree. So we found out all the parameters. So these are the values: V1, V2 after the collision with the angle of 20 degree and V2 with the angle of 86.049 degree. I hope you understood this problem. If you have any doubt, you can put it in the comment section. Thank you for watching.